Thank you. So this talk is about PHP under the hood, trying to explain a little bit of the things, how PHP works, what it's doing. The idea to this talk came from some IRC discussion where some person asked the question, which of these two ways to check for a feature is faster? Is it faster to use extension loaded or function exists? Of course, it's a stupid thing to do, to decide that on performance or anything, which one to choose, since you're doing different things. In the first thing, you're really checking, is the extension loaded? Can I use the extension? Can I draw some images and stuff? Whereas with the second one, you're actually checking whether you can edit PNG files. So you shouldn't use one or the other due to performance, but due to the purpose you want to achieve. But that made me start thinking about what can I tell about PHP, how does it work, so maybe people can figure out which one is faster. I hope I get all my slides done in time and I can give you the true answer, which one is faster, but let's see. Who am I that I'm going through this talk? I'm Johannes Schlüter, I'm from Munich, Germany, so sorry for my accent. I'm on Twitter, PHP Error. At daytime, I'm working for the MySQL engineering team at Oracle, focusing on PHP and MySQL interoperability. And at night, I'm involved in the PHP community doing the release management for the 5.3 series, which I always explain something like, if something is broken, it's my fault. If something great is in 5.3, I can tell you who committed it, and you can praise them. So I guess all of you know about the PHP lifecycle. So PHP is either run as a module in the web server or is running as fast CGI. So at one moment you have to start up, and then you have multiple requests coming in with a short startup, and then the script running, and then we clean up everything. Cleaning up, I will talk about it in a moment again, but basically creating a clean state again. I'm a bit confused since usually I see my slides there, but it doesn't work at the moment due to all this open office crap. That's why I always have to look there then. So one thing about the execution of a PHP script, which I think most of you should know, is that PHP is compiled into some binary form, which we call opcodes, which represents the PHP code on a way lower level. These opcodes are generated on each script request and then thrown away. And if you're using some bytecode cache like APC, then that's stored in memory. But from the pure PHP perspective, it's a clean state on each and every request. How does this opcode look? If you know some assembly language or something, you might have some, you might remember it a little bit. I don't want to go too much in detail. There's another issue with this open office stuff. Now it works. Sorry for that. I won't go too much into detail. This is a function call, so this is the same on that level for the both examples that I've shown in the beginning. That's the reason for the slide, basically, showing it would do the same thing independently if you do extension loaded or functions exists. It would do an initF call, then send some the variable to an internal stack, which is then later be used when the function is actually called. These opcodes then are being executed. So I try to have very little C code. This is an actual C code. It's simply something like it. By default, again, the stupid error, if I do have to load it 2 times, don't care, I don't know. So we have, for all these opcodes, like the assign handler and smaller handler, some functions which do the operation related to this. And then we have a long loop, simply always calling this function. Now, if you want to you can do some optimizations in PHP by using some other execution method, like you can compile PHP with send VM type equals switch, and then you get a large function, which a large switch, which has all, I don't know how many opcodes do we have at the moment, 300 or something. A long function, which breaks some compilers, which doesn't work. That's one of the reasons why we split it up. Or you can do another way, which works with some compilers, which is called computed goto, that it's going using goto pointer address and then doing that kind of stuff. I guess you usually won't have to know it. The important part there is it's compiled in some opcode and then being executed in some way. It's not really compiled into machine language that it's directly running on the CPU, but in one of these forms. Then interesting things we are also using always include, require, and the once versions of these. I guess everybody of you knows this, and does anybody know the difference between include and require? I hope that is the case. So include gives a warning if something fails, and require gives a fatal error. That's the only difference. So whatever you choose there, there's no difference besides that in the error case. The include once and require once are a bit more interesting, and I hope that's the next slide. And it is. So really breaking it down, what's happening on an include is the file is being opened and compiled in these opcodes and then directly being executed. Whereas when you're doing include once, we have to do a few more things. First, we have to make sure that we have the complete real path of the file name, so we can see whether the file has been included before, which is then the second step. Then we open the file, and if that works, we know, okay, we have this file included in the past, and on the next request, we won't have to, or next include once or require once call, we wouldn't have to do this. And then finally, it's being compiled and executed. So you can see that the once versions are notably have some more stuff to do, especially this resolving of the paths can take some time if you have a nested structure with symlinks and all that kind of stuff. Next thing we're having in PHP are variables. Again, a short quiz for everybody. It's a large audience, but how many data types do we have in PHP? 9 and 10, how much? So we have null, boolean, integer, float, string, array, object, resource, 1, 2, 3, 4, 5, 6, 7, 8 different types. Types which are often forgotten are resources or null. That null is a value and a type in PHP, since usually you don't have to care too much about types. Is that a question?
And is callable?
That's no type. So the question there was whether is callable, which we offer as a type hint, is a specific type, but it's only in the place where the is callable is implemented in the function calling area. There are some special handling, but for the variable itself doesn't carry the information whether something is callable or not. That's something which can be defined from reading it out, looking into it. For instance, if it's a string image create from PNG, it's a string. It's not a callable type. It's a string type.
Source disagrees.
Pardon me? Okay. You can come on stage. We have a microphone if you want to complain, but that's fine. Okay. One thing we are doing in PHP is we are optimizing for you that you don't waste too much memory in different cases. So what we are expecting in a case like this, here's some stupid stage. So we're having this function call, and inside the function you expect that you have a copy of the variable, and if you do an assignment, you usually expect to have a copy of the variable, and a copy usually takes some time, some space, not time. And then there's some change, and all these things have to do with copies of variables. Where on the other side, there's a feature called references, where references are aliases to a variable. So doing the same things with variables, that should all work on this big array. So all these changes happening here are shown in big array in the end and show up there. I hope that's basically known to everybody what references and copies are. Now we have an optimization in PHP that is copy on write, so we don't actually copy all the data all the time, but we copy it only if it's required to have a copy of the data. So I'm going through a simple example here. A variable inside PHP is represented by a z-val, which is the internal data structure used for these. And then there is some name attached to it, which is stored in some way and pointing to these z-vals. And I'm having some different variables, so I drew some boxes for the different things here. Since we're doing copy on write, we have to do some reference counting to know how many variables like $big array, $copy1 are currently pointing to this. So we have a ref count, reference counting field, and for handling references, we have a flag whether these are references or copies. So what happens in this case here, we start by an assignment of $big array with some large amount of data. And after that, we will have one variable in memory with a reference count of 1. If we then do an assignment, we don't actually copy it over to a second variable in memory, but we simply increase the counter, knowing, okay, now we have 2 variables pointing to this data structure, and don't waste time copying it. If we do it again, same thing happens, and ref count increases. So no additional memory used, but simple reuse of the memory. Now, if we change one of the copies, then we detect, oh, there's a change, and then we create a copy of the data of this array in this case, and create a new z-val, lower the reference count of the others. So copy1 and big array are still stored here, now having a ref count of 2, and a copy exists with a ref count of 1, since $copy2 is the only one pointing to this memory area. When we are now doing references, the R is missing, I'm sorry again. We're doing basically the same thing here. I'm calling a function which takes a reference, and so let's look into it. I have my ref count of 1 after doing the initial assignment. Then I do the function call. Here the difference is that I'm setting the isRef flag to 1, since we want a reference inside the function, and increase the ref count to 2. And then I'm doing something inside PHP, since basically all functions in PHP are created in a way to know about this reference counting and optimized in a way to work with reference counting very well. So basically all functions in PHP expect a copy of the data. And now we're having this isRef flag set. And if we're now creating a copy of it, we have to actually make a copy, since we have some references to it and we can't distinguish which should be the copy and which should be the reference. Yes, Derek?
The ref count is 3 in this case.
$data.
It is 3 because positional arguments also increase the ref counts, so that you can use func.args args together. So it has to be 1 more.
Okay, right. Thanks, Derek. So it's 3, but that's a detail. Oh, I simplified it to make it better explainable, to ignore the details. You should, so be careful about all the slides. Better check it in a debugger if you want to have the truth. It's only simplification. Okay, so by introducing this reference, which some people do for purposes of doing an optimization of the code, oh, I don't need a copy, I do a reference. What usually happens is that you create additional copies, which hurts your performance. So it's good not trying to be smarter than PHPers, but simply do the assignment if you want to have an assignment, do a copy if you want a copy, and PHP will figure it out in at least most of the cases what's really to do. So just to keep it again, reference asserted performance. There are even some funny things. Anybody knows the output of this PHP script? So I'm iterating 2 times over an array, and now it's working. So 0, 1, 2, 3, iterating 2 times, and then printing it. Obviously, this prints 0, 1, 2, 2. Absolutely clear what happens. For those who don't see it, 1 or 2 maybe in the audience. So we are iterating here and saying, okay, the $item should always be in reference to the current element in the loop on each step of the iteration. So in the first step, we create $item, and being that a reference to the first element in the array which we're iterating over. Then we are continuing the iteration, so $item becomes a reference to that element, and then we iterate again, and $item becomes a reference to that, and then it becomes a reference to the last element of the array. After the first iteration finished, we are having $item still available. PHP doesn't have a local scoping, but we have function level scoping. So $item is valid all over the complete function this is in, or the complete file, or whatever. And on the next iteration, on the second case of this for each, $item here is still a reference to the last element in this array there. So for each iteration there, the current element from the second iteration will be written into $item, which is a reference to this. So after the first step, the array will be 0, 1, 2, 0, since it's the reference there, pointing to each other. Then on the next step, it's 0, 1, 2, 1, and on the next step, it's 0, 1, 2, 2, and then it's overwriting itself by pointing to itself and keeping the 2 at the last element. Now, in some way, I thought, okay, that's a theoretical problem, but actually there are bug reports about this behavior. That are people really doing this kind of iteration, iterating 2 times over the same thing, or using references in the same variable. And then they want us to unset the variable, to not make it a reference outside of this iteration. But as PHP doesn't have the scoping that tight, but having the scoping bound to the current function, so all variables exist in a complete function, we can't properly do it, since there are sometimes cases where you, for instance, break an iteration at some termination decision. So you decide, okay, if this and this is the case, then I do a break. And after the iteration, you want to have to access to the last element you're working on. For instance, if you have some searching algorithm going through an array, search for a specific element, and after you found it, you want to do something with it, then you still have to be you still need a way to reference that current element, and therefore we can't unset it in any way and have to live with it. So, in my opinion, then there's a second issue with references, that in some way they create an API which isn't that intuitive. So if you look at this function call for a built-in function of PHP, you might not be aware when firstly reading it that it's actually changing the parameter you're passing to it. What might be nicer is if it would be returned instead of being returned as a return value instead of being returned as a referenced value. Might make the user interface, the user, when reading the code, way simpler to know, okay, it's in parameter, nothing is going to happen, and there's a result for this. There are a few exceptions where this can't be done and where some benefits there are, But usually I think it's better to have such an API and not use references for returning values. So another reason why I think that references are bad to do in PHP. So that's my biggest claim. Don't use references in PHP, small parentheses, until you really know that you need them, since they are there. Now people come and tell me, oh, wait, I was careful when PHP 5 came out, and the big change there was that objects aren't copied over when a function is being called, but are references. Well, no, they aren't references in that sense. What happens if you pass an object to a function is that the setval, the internal variable, is not holding the object itself, but is only carrying a handle to the actual of an object, which is then stored in some object storage differently from the actual variable. The effect there is that when this handle is being copied, you're still working on the same object in the end. So let's look at this, what this actually means. I have a function foo, which takes a reference, and then I assign the variable inside the function and change it from being what is passed to being null. And I execute this small script and I get null. Since a reference is an alias, so if I do anything in here, it has an effect on the outside. When I do the same thing with an object, so I'm passing a new standard class, passing that as a parameter, changing it inside doesn't have an effect on the outside, since the variable is different, even though that the object itself is the same. To explain this, I have this example here, which is another case where I'm having an array, passing it as a copy, making a change to the array, and that doesn't show in the outside. Whereas when doing the same with an object, passing an object and changing inside the function, it shows on the outside. So here's the print R, and the $foo exists, since we're copying the handle, still pointing to the same element in the still pointing to the same object. That's the right term. One second, please. Okay. So another important part is memory management in general. So most of the PHP memory management is focused on the case that we are in a web space, and a typical PHP script is running way less than a second. If a PHP script is running longer than a second, in most cases there's something wrong. So the reference counting mechanism is a good way to keep the variable memory intact. And then we have another mechanism, is that at the end of the request, we basically throw everything away. Every allocated memory which isn't freed in some sane way will be freed by force, and so we have a clean state at the end of the script run. Now there's one issue there, which are cyclic references. So here I'm having two objects in this case, which are pointing to each other. When I'm now unsetting those, the reference count there will still be 1, and they will only be deleted from memory once the reference count reaches 0. This was an issue within PHP 5.2 and all below, since we really relied on the reference counting mechanism, and everything else was thrown away at the end of the request. With PHP 5.3, no, I don't have it on the slide, we introduced a garbage collection mechanism, which will from time to time go through the PHP script and figure out, looking for all these kind of cyclic references where one object is pointing to the other and nothing from the outside is pointing to it. There might even be complexer structures, like you might have 3 objects or 4 objects pointing to each other. And with PHP 5.3, that's one of the things where object-oriented code oftentimes got real performance benefits. This brought an improvement. I forgot the beginning of my sentence. Then there's, with this cleanup at the script end, there's another issue, which is a kind of a hen and an egg problem. Meaning, what should be shut down first? Should we shut down first the session handler, which is depending on an object and writing a file to a file stream? Or should we first delete the file stream, which is referencing an object which implements the stream? And which order should we take there? Over the time, there were some small changes, and all of them always got a problem. And that's basically the order we are currently, with an S, having in the system. So we call it a shutdown function, so you can do a register shutdown function and define a callback. Those will be executed first. Then we call all the destructors, flush output buffers, send HTTP headers, shut down the extensions. This triggers the session handling code, for instance, to finalize the session handling, destroy superglobals, and then delete everything, which is remaining. There are some issues sometimes with this order, but we're not going to change the order until there's a really good way to do it, since every change there causes another issue, and the current one works for at least 99% of the cases, even more, I guess. Now, let's get back to the beginning of this talk. Which is faster, extension loaded or function exists? So who says extension loaded is faster? Who said function exists is faster? Who says it's the same? Nobody's saying the same. Interesting. Okay, let's look at the implementation. Just to have some C code in the slide. This is the implementation of the extension loaded function. And we're having some variable declarations. We're getting one parameter, which is passed from the user of this function. Then we create a copy, which is lowercase, since the extension name is compared only lowercase. So you can't have MySQL extension with capital M and a MySQL extension with a lowercase m, but you can only have one of those. So we have to lowercase it to compare it. And then we look up in a hash table whether it exists or not. Okay, that's the implementation. Then that's the implementation of function exists. There we have to do a bit more stuff. The small written stuff is the same stuff as like in extension exists. But we have to do two more things. One is if we are in PHP 5.3 or up, we have namespaces. So people might paste the name starting with a backslash, but the backslash is not stored in our function table, so we have to get rid of it. That's a very little extra cost we have in this execution, which you barely can measure at all. Depending on your CPU, you even can't measure it. And then there's one thing we're having in PHP, which is the disabled functions setting in the PHP INI file. And there's a second check we have to do to see whether the function is disabled or not to return the correct value. Now from this, we might say, okay, this one is the slower one. But we have one black box in here, which is the send hash find function. And send hash find goes to a hash table, since hash tables are the primary data structure we're using in PHP, basically. So everything in PHP is stored in a hash table. The object storage is a hash table. The arrays are, in fact, not arrays, but hashes. The function list is a hash table. The class list is a hash table. And what else there is in PHP, it's always a hash table. Well, not always, but you know what I mean. And how do hash tables work? Well, I wanted an age. Okay. So what we are having is, we are having a data structure where we're having a key, which can be any string, and then we want to reference some data to it. Now when we are looking at the machine level of our system, we have our memory area where we can have the addresses, so we can have a simple array basically as a data structure where we can count, okay, I want the first element, or I want the 10th element, or I want the 25th element, or whatever. I need such a data structure where I can simply jump to the correct address. Now I can take a hash function. A hash function is a function creating a numeric representation of any string you're giving it. So something like MD5 is a quite expensive hash function. Even if you're seeing some letters in your result, that's just because you're having a 16-bit hexadecimal representation of the data and not a numeric value. The MD5 could also be represented as a large numeric value. And basically, that's what we're doing with the hash function. We are using the, what is this, DJB33 hash mechanism, which is a relatively fast hashing function, which works quite well, giving not too many conflicts. It's not crypto safe like MD5, not like some of the SHA hashes. It's not crypto safe like those, but it's hopefully good enough. I'm talking about it in a second. And we are getting a number. In this case, the value foo bar is being translated to this number, which I won't read out. Now, if I want to, now I could use this number as an address in my memory, which would mean I would need to have a memory area which could fit that amount of values inside my memory area, which is a bit much, since I have to pre-allocate space for all these elements. So what I'm actually doing is I'm reducing it, throwing away the first few bits of this value, and just apply a table mask and get a smaller value. If you want to know what's working here, I have the binary mask there. So the table mask has a value where all the bits are set. Table mask usually is a value roughly a bit higher than the amount of elements you're having in your array or in your hash table. And then this is the binary representation of this value. And if you do a binary AND operation, you only get the last digits, and all of this in front would be zeros. So I didn't write them down here. So now we're having a quite smaller value. And now for this case, we might have a memory area which doesn't require that amount of values, but that's the maximum 2047, and that's manageable in memory, and we can allocate the memory and put it there at position 126. Now we did do two things. We had a hash function, which isn't crypto safe and has many conflicts, and we are applying a table mask, which is throwing away most of the information again. So 1/3 of the bits is only left in our final information. So what the result of this is that we're having lots and lots and lots and lots of collisions. Probably, I don't know, depends on the case. And what with the collision happens inside the hash table is that, in fact, at the memory position 126, it's not storing the actual element, but it's having some data structure which is a linked list. So we can have multiple values at the same position. So a lookup would be calculating that value, going to the address in memory, and then if there were some collisions, go through a linked list to find the actual element. And now we are getting to the issue why you all should upgrade to current PHP releases like PHP 5.3.10. Since it was discovered that there was a small issue with this handling here that, as I said, everything in PHP is a hash table, so $_get, $_post are hash tables. And an attacker could create post values, which end up with the same value here, 126, for instance, and create a post request having lots and lots and lots and lots and lots and lots and lots of these values in there. And this creates a long, long, long linked list. And for each operation, this $get array, we have to look through this long linked list. And that takes some time. And that created a possibility to create a denial of service attack, a DOS attack, which slowed down the operation since the CPU was running through this list and finding the element. So that's the reason why you should really update to a current PHP version. We had a small issue while doing the fix, so we didn't have only 5.3.9, but 5.3.10. Not very good, but that's life. And so update to the latest version. And that's basically the overview I wanted to give you about some of the workings of PHP. If you have questions, we have a few minutes left, so I'd be happy to answer the questions. If you want to rate a talk or want to read the slides again, it's all on this URL. If you want to praise me on Twitter, that's my handle. There's my URL and email. Thanks. Questions?
You know, when you were explaining the cycling references,
yes,
and the garbage collection and stuff like that, how would you solve that, for example, because you don't have it in 5.2, for example, right? So if you want to unset it properly and reset the ref counts, would you have to unset all the properties manually and then the object itself, or is there any way of doing it actually?
There's a perfect way for doing this by upgrading to a better PHP version. For instance, for this issue, that's a good reason to update from 5.2 to 5.3. And seriously, yes, like you said, you would have to do it manually, unsetting all the references. Any other questions?
Which was the faster in the end? Which was it the GD?
It depends. Okay, sorry, I forgot to mention. Thanks for reminding me. I would have it in the notes, which I can't see right now. So what actually happens is there are some cases where we have some conflicts in the function or in the extension list. So I have a case where I did dump these lists and dump the hash values, and I had a case where 3 functions shared the same value, and then if you hit it, it was slower. If you didn't hit it, it was faster, so it depended on the function or on the extension you're looking at, which then depends on your configuration, how many functions you have, so I can't tell you.
I won't worry about it.
Since you shouldn't really use such features depending on performance, but make the code readable. If you want GD functions, check the extension. If you want a specific function, which might be optional, check for the function, and that's the way to do it.
And make sure you name your functions correctly, so you get the hash values that don't collide. I actually did that in the early versions, PHP 1 and 2. My hash was the string length of the function. So it was didn't have very many buckets. There were lots of linked lists, but I would name functions such that it went into one of the buckets that didn't have very many collisions yet. So some function names were slightly longer, slightly shorter, just to get them into the right bucket.
So one question I've been asked a few times, I never know the answer to. If I've got, over here.
There.
So I've got some values in variables and I've got some literal strings and I want to combine them all into one string. Is it faster to concatenate or is it faster to have the variables inside a double quoted string and interpolate?
Good question. Benchmark it, profile it.
We actually did.
So, and what was your result?
We had two different results.
So,
Smaller strings, it worked. The variables inside the string, bigger string, concatenation.
so an issue there is about the amount of copies and reallocations and how much memory is being allocated, where I guess you can't make a good prediction in a good way.
Will that be better to leave that to PHP optimizations? And
Well,
think about it?
So a comment was whether we could do some optimization in PHP for that. We are not doing optimizations while compiling the PHP script. That's where this should happen. And so we don't have that. Since basically when we're compiling the PHP script, we're looking at the situation that we're throwing it away anyways again at the end of the script. So spending much time on optimization doesn't benefit us there. So one might think about it, but it's currently not on the high priority list.
I want to ask about when the destructors are called. Is the destructor called when variable leaves? When you have the reference count as 0, or could it be delayed until garbage collector kicks in?
You have your object, and the object has a destructor, and the variable, including the object, is freed when the reference count is reaching 0. So at the end of the function, if it's the last reference to the object, then the destructor will be called at that time. If there's a cyclic reference and the GC runs, then it will be run during that GC run. If it's in shutdown, it will run during that shutdown time in that order I was showing before. Another question there.
This is a bit general, but do you have any advice for people looking to get involved in the development of PHP?
Yes, you go to a recent URL, bugs.php.net/random, and you get some current bug you can look into, which might be a bit hard to figure out since there are many bugs which are a bit complicated. Then I don't know what your previous knowledge about it is, but to make it a bit general, there are different ways to help out the PHP project. Some do have to do with C code, and many don't have to do directly with C code. Like going through the documentation, we have this edit.php.net editor where you can anonymously log in, edit the PHP documentation, submit it as a patch, very helpful, since documentation is one of the things which made PHP really, really successful. Then you can go to the bugs page, as I mentioned, look through the open bugs and start just writing a comment. Yes, I can verify it. Here's a shorter reproducing case. You might try to look into the PHP code to do this. There's a website called lxr.php.net, which is quite nice to browse the PHP source code, to search through it, and each function, and there's a link leading you to the definition. And that's all for self-study. You can also get some books about PHP internals. There's Sarah's book, Extending and Embedding PHP, which explains some of the basic stuff about PHP. And if all that doesn't help, there's an orphan-friendly IRC channel on FNet, php.pickle, where many of the core developers are and help answering questions. And then there's the internals list and the pickle dev list. While internals, you sometimes have some flame wars, and pickle dev, you have sometimes more productive answers.
Okay, I just got one little question.
Yes.
Could you go back to the page shutdown sequence?
Yes, in a second. I was just looking for the other thing at the same time. Yeah.
And the reason I asked this is someone once asked me and I didn't know the answer. If I put a print statement in a destructor of an object which is in a session, will I see the printout?
You're in a session. A session is finished at that stage. What did you else have?
If in the destructor I've got a print statement,
Okay, the destructor
and
is
the
being,
object is in the dollar session
yeah, the
variable, will I
destructor
see
is
it?
being called quite early before the output buffer is flushed.
Even though it's in the session?
Yes.
Okay, cool. Now I can now answer his question 2 years too late. Any other last questions? Oh, one more.
In a long-running PHP script,
Yes.
how often, when does the garbage collector run?
So the garbage collector, I'm not 100% sure, but I think it depends on the amount of variables you're having. And that triggers it at some random time. But you shouldn't rely on it. You can trigger it if you really know now it's a good time. For instance, after running a huge test case or something, there's a function gc_run or something like that. Collect cycles, gc collect cycles, which will trigger the garbage collection. But usually the best thing is not to care too much about it, since all these things might change and then behave a little bit different on the next version. Usually PHP tries to be smart enough so you don't have to try to be smarter than PHP. It's always a little bit problematic.
So you say that the destructor is called when an object goes out of scope. Is the memory freed up at the same time, or does that happen in the garbage collection cycle?
Pardon me?
Sorry, the memory of an object, is that freed up when it goes out of scope and the destructor is called, or in the garbage collection cycle?
In the shutdown, I think here, in the shutdown case, when calling the destructor, it just calls the destructor. It doesn't.
Just when an object goes out of scope.
And when going out
naturally.
of scope,
just
after
stop
calling
it.
the destructor, it will be freed
Thank you.
and thrown away.
Yeah.
So in the example that you had with the function and passing a variable in by reference, and you
Yes.
said don't use references. So let's say you've got a function and the function needs to modify a global variable. So you could do it by using global variable name, or you could do it through the global superglobal. What's the best way of doing it then? If you've got a function that needs to modify a global variable, if you're not passing it by reference.
So if you want to change something globally, let me think. If you use the global statement, you're basically creating a reference which isn't from the cost or something, not too bad. If you're using the $global array, that's directly going to the hash table. Shouldn't cost much either. So from the cost side, there's no big difference. Then again, it's more about coding style and what you prefer for your code base to look like. I try to avoid any discussion about which is nicer to read or something like that, since that's a quite subjective question. And I guess that's what it boils down to.
So there's no real difference.
Not that it's really notable.
All right. I hope there's no more questions because we've run out of time. Thank you.